Disability sport's really interesting. It really understands its relationship with science and engineering.
I've worked with a Paralympic athlete. He had so much energy, it inspired me all the way through. Mechanical engineering it's being able to see the hands-on product. You can see the actual component or system being made, you can think about how it's going to work, and you can potentially solve problems that occur.
Without these pieces of technology, disabled athletes would simply be unable to do what they do. These technologies are fundamentally enabling.
Wheelchair basketball has sort of evolved and moved on so far from where it was maybe 10 years ago, maybe even 5 years ago. And because of disabilities, they have different setups, different designs. We're now into a new production chair with UK Sport. They're helping us develop this chair. But one of the key things we want to look at, particularly wheelchair basketball, is speed and power. So not just about the push and how much power that generates, but how quickly you get your hands back into the starting position, push again, and can you replicate that power continuously? And that wheel really makes a lot of difference.
This is the power wheel. This particular one is mounted on a carbon fibre racing wheelchair wheel. As you can see, it's got some electronics on it. This side is the push rim, so it would fit on the outside of a racing wheelchair, and it actually provides a measure of force and power back to the athlete and the coach. So as they push the push rim, make them go along, there's sensors inside these links. They provide an electronic signal through some electronics on this side of the wheel. So we've got the 6 instrumented links hidden behind covers. We've got signals coming from strain gauges on these. The wiring runs all the way back to a box of electronics. We've designed the electronics in here that then provide the signals to a wireless link. That's sent through the air to a wireless receiver that's connected to a laptop. It processes the signal and it gives an output to the athlete. So that's live feedback at the front of their wheelchair. Some of the data that we give them is power for the push that they've just given, how many pushes they're doing per minute, speed they're travelling, how far they've done in that particular session, and how long it's taken them.
Disability sport, the Paralympic movement, was a scientific idea about rehabilitation, came out of a hospital, so it's intimately wedded to science and technology. A really good example of the relationship between engineering, science and technology and Paralympic sport is of course Oscar Pistorius, the so-called Blade Runner. I mean, this is an athlete who's dominated the Paralympic movement in terms of his incredible performances. Here is a guy who's running as fast as the very best in the world, certainly a heck of a lot faster than I could ever hope to run. Well, this challenges the whole notion of what disabled means. I think we're going to have to come up with a new word, because in many ways he's super able. And of course, technology is very much a part of that. There's huge potential to not just enable the athlete, but to actually enhance the athlete. Where could we go with this? Where could it lead to?
I worked with a Paralympic athlete and he was absolutely incredible. He had so much energy, it sort of inspired me all the way through that he really wanted his kit to be the best, and I just wanted to give him the best design that I could. I'd quite like to feel that I'll play a part, combined with his huge sort of sacrifice that he makes to actually getting success and winning some medals. So I'm always going to understand that it's the athlete's made a massive sacrifice and my part is small but there, and I definitely feel a connection to that sporting event, and I will be on the edge of my seat.